fed up of the football? Your team's gone out? Well, let's talk cars instead. This week, we're at the Grand Prix. We're in a do-it-yourself driving car in India. And someone get Jen a new umbrella.
The seconds wound down before the start. 24 drivers stamped hard on the throttle.
Formula One has been at the cutting edge of technology and design since its creation in 1946.
Welcome to the pit.
Every year, teams compete fiercely to outdo each other in aerodynamics, data communications and materials, all with one aim: to make their cars go really, really fast.
And they do a really good job of making them that, as we are finding out here at the Austrian Grand Prix. Lewis Hamilton's ride.
What's even more impressive is that this whole show is permanently on the road, with car, teams, engineers and scientists moving from country to country and track to track.
Now these are the most expensive motorhomes I've ever seen. Each one of these is a lorry, and they just drive them to the next Formula One, stick them together, zip, 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 and that's Ferrari's office for the length of the race.
And ahead of the race here in Spielberg, Austria, the cars are being prepped, tweaked and tested round the clock.
Mercedes are the current world champions, and like every other team here, they spend millions on their car and developing the technology that will hopefully win them the race. But what you see at any Grand Prix is just the tip of the iceberg. It takes hundreds of people to develop that technology. So we sent Laura Lewington to Mercedes HQ to find out what really goes into winning a race.
Away from the track, the people, the preparation, the planning and the precision are pivotal.
Hi, I'm Laura Lewington from the BBC.
Hello, can I just put security stickers on your phone?
Of course,
On the cameras?
no problem. So we're allowed to film here, but I mustn't take any pictures on my phone. There's clearly a lot at stake here, so it's no surprise that Formula One is notoriously secretive. But today, we've got some behind-the-scenes access.
This business is big bucks, and millimetres and milliseconds matter.
This is known as chassis number 5, last year's winning car. In fact, it hasn't even been cleaned since its last race in Abu Dhabi. But the thing that is most striking standing here next to it is the amount of detail there is everywhere throughout the car. And after each race, if there's something they're not happy with, it can be perfected. Well, this was a winning car last year, so clearly it's been very successful, but you're obviously not happy with it because you're working on a new one. So what do you think needs to be improved?
We're never happy with it, as you say. This is Lewis's car from last year. It was the first car we made on the back of a really big regulation change. We worked really hard on all those little small bits you see around the car, which is all the aerodynamic bits and pieces.
It seems to be made up of lots of little small bits.
Yeah, every little bit has a job. When we put it into the wind tunnel, each one is all about optimising the airflow around the car. What we're not happy with a little bit is, because we focus so much on that, we now need to do a lot on the packaging internally to make it much tighter. The tighter you get it, again, the better you can get the aerodynamics around the car. On top of that as well, we think we can do improvements around the cooling. Those big black ducts on the side is where the air goes in to cool the engine. We think we can do some improvements around that area as well for next year.
Well, there's so much money at stake here. How much does it cost to create a car like this? From the beginning of the process, all the way through, what sort of figure would you put on that?
Well, I can't tell you the exact figure, but I can tell you it's many, many millions.
Are we talking tens of millions?
Tens of millions.
Tens of millions?
Yeah.
Over
Yeah.
50 million?
Close.
Crikey, wouldn't want to pay the insurance premium on that. The operation here goes way beyond the car itself, though.
Welcome to the race support room. When a race is actually on, 60 members of the team are allowed to be at the track. So this provides the opportunity for more people to be looking at the data and making sure that vital advice can be provided. Now on these screens, they'll be looking at a feed from the race. They'll also be looking at feeds from within the drivers' cars, plus all the vital data that they want to act on. And if they want to communicate, well, they simply do it through a pair of these. Lap times, GPS data, everything can be tracked and analysed here, where 5,000 different data points are being assessed. Information from races in Europe taking just 0.1 of a second to reach here, or 0.4 if the data is coming from Australia. Meanwhile, this lot are busy practising at speed. Over 250 of these trials take place ahead of the season. They make it look easy, but inevitably it's not, as I can tell you firsthand. Oh, oh no! So loud and it's meant to be so quick, but I clearly wasn't. Meanwhile, Spencer's already living life in the fast lane.
Thank you, Lara. And by the way, this is how you really do it.
This year, Mercedes has got its pit stop down to an incredible 1.85 seconds. Now, that's quicker than it takes to say 1.85 seconds. It's a finely tuned operation that the engineers practice over and over in the days before each race.
It's a bit of a ballet, and the ergonomics is quite important, because it's 20-odd people around the car trying to do a job in 2 seconds. And if you start banging into people, then you're losing half a second, and then the strategists can't get their numbers right, and then you don't get the position you need.
The human element to this ultra-fast manoeuvre is accompanied by technology individually developed by each team. Even the hydraulically powered wheel guns are a closely guarded secret.
And I hear they're quite expensive.
They are expensive, and they have a life because they run an awful lot of pressure. So we're changing the internals a great deal.
Do I hear about £30,000 each?
I wouldn't know the exact cost, but that sounds quite low to me.
Right, we're going into Mercedes' garage now.
Keeping the pit crew safe is of utmost importance. These lights, for example, let the crew know if the cars have become electrified, stopping them from getting more than a nasty shock. And then there's what goes into the cars, or more specifically, what comes out of the cars, which is monitored by trackside labs and high-end scientific equipment.
Between every session, the cars are given the equivalent of a blood test. The oil and the fuel is taken to see if it's contaminated, and that might give you a clue as to the state of the engine. And that is done in the fuel lab.
The oil is put into a spectrometer which tests for different metals in the fluid. The amount of a specific metal present can reveal if a particular part of the engine is degrading too quickly. Yes, these may be some of the most skillful drivers in the world, but I wonder if even they would struggle with driving in David Reed's neck of the woods.
Okay, here we go. This is maximum chaos. Guy just overtakes me on the inside. It's crazy. Got a car sandwich. Yeah, that's me. Thank you. Driving here is tough. I reckon if Western autonomous car makers came here, they would hide in their hotel rooms. But Indian inventors, they see the chaos on the roads here and they want to take it on. Look at this mobile footage. This rickety second-hand SUV has been made single-handedly into a self-driving car. It's a bit rough, but it makes it down the sort of road that gets wing mirrors very worried indeed. The man behind it is Sanjeev Sharma, a US-educated AI specialist. He says the maths that navigates his car, the algorithm, has been designed specially for India's nightmare roads.
Indian traffic is very chaotic. So it's very hard to predict. Once you solve that prediction problem, then you can apply that in any structured environment and it will work because you already have tested in the most difficult conditions possible.
Today there's a hitch. The car's refusing to drive itself. So Sanjeev takes the wheel.
Recognize gates.
Top-end driverless cars cost a bomb. They're developed by big teams, have pricey radar and lasers, and use big data maps to find their way. Sanjeev's is cheap, but not short on brains. His off-the-shelf cameras talk to an algorithm that reads the road, even without maps. India's government is against driverless cars because they fear job losses. But the tech being developed here could still travel far, especially with the advent of artificial intelligence. Now, whether or not at some time in the future India will have driverless cars is very debatable. However, the same technology can be used to make India's roads safer. Many here place their faith in dashboard-mounted gods to protect them.
Please maintain safe distance.
But with 150,000 dying on India's roads annually, Driver Eye, a hazard warning system developed in Bangalore, might also merit a look in. So why did it go there?
I was too close to the two-wheeler and I was about to collide. That's when the event got detected.
And it's just as well because they were policemen. Driver Eye is a clever backseat driver.
So this is the front camera.
It measures acceleration, orientation, and has 4G, but also artificial intelligence. It learns what's safe and what's not. It's helping Indian truckers drive better.
We're tracking every single object on the road, and we're basically measuring any unsafe and identifying any unsafe event. We actually identify what the driver's maneuver is and whether the driver maneuver corresponds to a positive maneuver or it was actually something that the driver can be coached and improved upon and the driver did something that could be considered unsafe.
Like our run-in with the cops, we got the video because Driver Eye sent it back when the warning sounded. One rather surprising area where driverless technology is making inroads is actually off-road. In Chennai, one of India's main car makers is developing self-driving tractors in response to low crop yields and a lack of farm workers. Tractors can work around the clock, just what you need when you're up against a short window for sowing or harvesting.
When it has to happen, it has to happen right at that time. Otherwise, you can actually use the entire yield for the season. It's not an easy piece of equipment to drive because you don't want the wheels to run over the ceilings every time. So every time can you get the consistent operation, and that can be done only by technology.
On or off-road, self-driving tech has incredible potential, helping out farmers, disciplining unruly drivers, and harnessing chaos as a testbed for even smarter systems.
Hello and welcome to the Week in Tech. It was the week that Facebook faced a fine of £500,000 for breaches in the Cambridge Analytica data scandal. And we learned the scale of Apple's autonomous vehicle ambitions. A court filing accusing a former employee of stealing trade secrets has revealed that 5,000 of the company's staff know about the project. The smartphone Supremo has remained notoriously tight-lipped on the issue. Across the channel, a family in France have become the first to live in a 3D printed house. Their cement-filled home in Nantes was built in just 54 hours, but the city's university and council behind the project think they could do it all again in just 33. Its curved walls make the property less humid, and the construction costs were 20% cheaper than using traditional methods. It was also the week chipmaker Nvidia showed off its photography skills. Using deep learning, it's trained its AI to fix grainy or corrupted images. Amazingly, it's learnt how to do this having only seen corrupted ones, which means it could make restoring poor pictures a little easier in the future. Magic! And finally, MIT have designed a musical instrument specifically for space travel. The telemetron contains chimes equipped with gyroscopes that change sound depending on how they're shaken, allowing budding astronaut musicians to beat the box in 0G.
The stats for Formula One are mind-blowing. These cars come around this track at over 350 kilometres an hour, and that's why 350 million fans tune into these races. But attracting new viewers is a bit of an issue for this sport, because watching these cars go round and round and round and round can get a bit boring.
Formula One are aware of the problem, and part of their strategy is to use all the latest tricks and technologies to pull in new fans, especially those who play racing video games and are used to feeling like they're really sitting in the driving seat.
Sport broadcasting technology is moving at such a pace. You know, everybody's talking about, as we said, 3D, 360, virtual reality. You know, that's a big talking point at the moment. Mixed reality is quite nice as well. So whether that's bringing in actual footage into the CGI world, it works really good as an engagement tool.
The demographic for a Formula One fan, I believe, is a middle-aged man, and we wanted to make it available for young people, boys and girls, all sorts of people.
This year, every Formula One car has one of these 360 cameras right on the front.
That's correct.
And why have you done this?
To give the public a more interactive feel, so you can actually go wherever the action is. And if you record it, you can watch it back in whatever angle you want.
And have you tried this? What's it like when you've actually looked through the goggles?
We haven't found anybody who hasn't been wowed by it. It's our intention to eventually stream this live off the car, that you can pick your favourite driver and have an experience with him going around the track.
But while this may be a great experience for the viewer, the teams, which consider every centimetre of these cars, might not be so happy about Formula One's mandatory addition.
The original camera we used was the size of a cricket ball, but this obstructed the driver's vision, and so we repackaged it and got it down as low as possible, and this is the design we come up with. And I think the balance of what you achieve from the penalty outweighs, the good outweighs the bad.
And the experience is not just about what you see, it's also about what you hear. As F1 cars have developed, that iconic engine noise has died down, and so Steve and the team plan to rev it up once more.
It's been a long-held desire of our audio department to mount a microphone in the exhaust.
How hot does it get inside an exhaust?
Up to 360 degrees.
Right.
With this as a microphone we had on Lewis Hamilton, it touched the exhaust and you can see what happened to it. Now it has to live outside of bodywork. It's heat resistant to 1,000 degrees, I think. And when they come to a corner and they change down, they go zoom, 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 zoom. Before it wasn't very emotional. Now when you listen to it, it really is a rasp. It's a really emotional sound. We've had lots of feedback from around the world, from broadcasters alike, and everyone loves it.
Even broadcasting these races is a huge operation. From Australia to Bahrain to China, the broadcast centre needs to be built in a matter of days to beam this race out to more than 200 countries.
The most amazing thing about this broadcast centre is not all the screens and all the technology, impressive though it is. It's the fact that at the end of the race, you just fold up these desks, put a lid on it, and it's already in a load of aircraft containers ready to ship to the next race.
There's about 200 tons of equipment in this building, which takes up about 2 747s and 24 trucks, effectively. So, and the idea is, look, how quickly can we get from one race to the next race? I think it's the biggest mobile broadcast centre in the world that moves so often. And as you say, we come along, there's a concrete patch the circuit provides, it provides water, and away we go. We build our home. Exactly.
Last Sunday you finished a race, and by Thursday at 2 o'clock you've come all the way to Austria and you're up and running.
Yep, exactly. And next Thursday we'll be in Silverstone, fully ready. And
look at the man, he's not
go.
even breaking a sweat. It's like, yeah, whatever.
And actually, it looks like the most stressful job this week is being done by Jen Copestake, our star in a reasonably priced, if somewhat weather-beaten, car.
Yes, Ben, I'm braving this hurricane in Cologne, Germany, to experience Europe's most advanced weather testing center for cars. Ford have built the $108 million facility to see how its popular models fare against the most extreme conditions on Earth, from altitude, high heat and humidity, snow, and hurricane-strength winds and driving rain. There are 3 wind tunnels here and capabilities of testing up to 10 cars at once.
Well, I pretty much control these facilities, and I conduct those tests. Yeah, we have like sensors, of course, for relative humidity, for solar simulation, for the temperature, and for the airspeed, which is measured through differential pressure from the nozzle to the plenum.
First, we're going to see what it might be like to drive your car in a rainforest. It gets up to 55 degrees in this room, and the humidity can go to 95%. Whew. This is one of 4 temperature-controlled test chambers, complete with birdsong and fake palm trees to simulate a tropical environment. It's baking in there. That is so hot. From extreme heat to extreme cold. Oh, that's the snow room. These doors are really heavy. It's about minus 17 in here right now. But the temperature can be set to go as low as minus 30.
Minus 30, of course, is rather important for cold starts, is important for HVAC issues, like for the heating system, for comfort, and for safety, of course, because we have a defrosting of the windshield.
They're also testing how the windshield wipers operate under heavy snow. The snow is falling from above and can test the maximum stress on different parts of the car. This is impressive. So it's testing the weight of the snow on the car, because this is actually a realistic situation in some parts of the world, to get a big snow boulder on the mirror. Next, we are going to see how cars are tested in hurricane conditions.
We are a climatic wind tunnel, so we always control the wind speed to simulate that the car is actually moving on the roads. We move the wind.
So it's actually 156 kilometers an hour winds out there right now. It can go up to 160 kilometers an hour. It's testing the automatic function of the windscreen wipers, so whether or not there's an equal amount of time going between each blade. The tunnel doesn't just test the rain and wind, but also the effect the sun has on the car in extreme conditions. It's set up with 28 spotlights with 4,000 watt bulbs to mimic sunlight.
The solar system is always interesting when it comes to heat loads that infect our powertrain and that infect the AC performance.
That really looks like being outside in bright sunlight.
It pretty much brightens my day every time I can use it.
The ability to test cars at high altitude while also simulating challenging weather conditions is the unique feature of the test center. They can reach heights of 5,200 meters, as high as Mount Everest's North Base Camp. Engineers even have to take descent breaks when they finish working in this tunnel.
More than half of our vehicles are sold in markets globally with altitudes of more than 1,000 meters. We can also simulate here pulling a trailer up the hill on different altitude levels. So testing the powertrain regarding what's happening in terms of temperature, how is that developing, and making sure that the cars are safe.
Well, we've seen everything here, and I, for one, am looking forward to getting back to some nice British weather.
That was Jen. And that's it from the Austrian Grand Prix. I hope you found it as thrilling and strange as I have. You can see a lot more photos up on Twitter. @BBC Click is the address. Thank you very much for watching, and we'll see you soon.